Happy Monday. Starting to look at integration more in depth. You already know what an antiderivative is. You already know fundamental things happens and how to evaluate it. And we have looked at change of variable already. That was calc 1 through 7. Integration by parts. So integrals of that form. F of g of x times g prime of x dx. Alternatively, we will write it as u dv. There's the formula. U times v minus the antiderivative of v du. Derivation can be found on the video. It's posted. And then we have if it's an actual integral. Same thing, except now you're evaluating each piece from A to B. Better. So you looked at all the basic functions in Calc 1, right? So you know what the antiderivative of sine is. You should know the antiderivative of tangent, secant, e to the x, log. The only ones we couldn't do in Calc 1 were the inverse trig functions. We're going to look at those now, or at least some of them. Starting with inverse line. When doing integration by parts, we want to pick a u, and then whatever remains is our dv. General idea behind picking the u is you want your u to be the function whose derivative is simpler. So there's really only one function, so that's why it's its inverse sine here. Then dv is just dx. We now need du and v. Start with the easier one. What's v? Just x. Technically plus some constant. We're just going to choose the simple antiderivative, which is where the constant is 0. So it's going to get absorbed into the final constant anyway. So we can just ignore it. Du, what's the derivative of the inverse sine? One over the square root of 1 minus x squared. Now the dx is just a differential. Like we're finding du, not du dx. We just use this formula. Our antiderivative, u times v minus antiderivative v times du. How would you find that antiderivative?
By parts.
You could. It's not going to get you anywhere. I think you're going to wind up back here somehow. There's an easier way. It's Calc 1. What's the derivative of 1 minus x squared? That minus x dx. This is u sub. Let u be 1 minus x squared. I need a -2, or just a 2, actually. Remember, you can't multiply by 2, but you can multiply by 1. So multiplying by 2, and then multiplying my result by 1/2. Now this is just u to the minus 1/2. What's the antiderivative of u to the minus 1/2? Just the power rule for antiderivatives.
X n plus 1 divided by n plus 1.
So u to the minus 1/2.
X 1/2 divided by 1/2.
Which is
2 multiplied by x 1/2 power.
but u was 1 minus x squared. There's your antiderivative for inverse sine.
So can we just go over this step again? Like
Which one?
With substitution.
Right, so u is 1 minus x squared, right?
Okay.
Du, negative 2x dx. Right? So this derivative times dx. The 2 here, 1/2, right, multiplied by 1. Well, there's your du, right, minus 2x dx. So plus 1/2. Now it's just the antiderivative of 1 over the square root of u. That's what it becomes with u sub. Right? See that?
Hardly, but
That part's u, right?
Yeah.
So that's where the u here is. Negative 2x dx. So essentially what I'm doing is I'm now bringing this negative inside. That whole thing is du. That becomes du, this just becomes square root of u. Right, so that's
so
what
like du, there's another substitution.
well, the du substitution is negative 2x dx.
Okay, so
So that's where the du comes from.
okay. So would you like 2 substitutions?
It's technically one, but yes. Right, 'cause what we're doing is we're writing this, it's called change of variable. That's why I don't like substitution. We're changing the variable from x to u. U, which means I need to change my differential into a differential for u, which is why we need the negative 2x dx. And then this is just a simple top 1 integral. Simple power, right? 2u to the half. But what was u? 1 minus x squared. So a half times 2. U to the 1/2 is the same as square root of 1 minus x squared. See that? And then, don't forget, constant integration. And we have antiderivative for inverse sine. What about the inverse tangent? What is our u going to be? It's going to be a similar choice. There's only one real option, the inverse tangent. What's left is dx, so that's our dv. Once again, v is easy. V is just x. And du. The derivative of the inverse tangent function. One over 1 plus x squared. U times v minus the antiderivative of v du. How do you do that antiderivative? So what's the derivative of 1 plus x squared? I have an x dx, I'm just missing the constant. What is the antiderivative of 1 over u?
Trying to get the power leader?
Hmm?
Over you power?
That equal. Windbreak was too long. Natural log of the absolute value of u. Can 1 plus x squared ever be negative? Technically, it can. If I let x be 2i, you get -3. But we're not dealing with the complex plane, we're only dealing with the real plane. So, no. In the real plane, 1 plus x squared is never negative. I can drop the absolute values. I don't like that answer. I actually rewrite this in a few different ways. That's one way. Logs all the way back in pre-calc. I can also get rid of that negative, but then that just makes this log look uglier. Could write it as plus log of 1 over the square root of 1 plus x squared. I think that's the one that's in the table when it's handed out. So I'm just going to stick with that one. They are all technically correct. The other three inverse trig functions will be for you to derive. As before, u is going to be the inverse cosine. That leaves dx, so dv is dx. V is just x, and du, the derivative of the inverse cosine function, is the negative of the derivative of the inverse sine. And all those derivatives are, of course, on that derivative table that's posted. U times V minus the antiderivative of V du. We found that antiderivative already. That antiderivative is negative square root of 1 minus x squared. There's your inverse cosine. Remaining 3 I leave to you. I did misspeak, we haven't actually done logarithmic functions yet. In Calc 1, you couldn't have done it in Calc 1. Because it does require integration by parts. We're just going to look at the natural log. I'll leave the general log, and log of a general base to you. What do we think our u is going to be? So dv will just be dx. What's du?
Is it gonna stay the same?
It's the derivative of natural log of x.
We'll go for x dx.
1 over x. U times v minus the antiderivative of v du. Oh, that's nice. What's x times dx over x? Oh, we were thinking of that.
dx.
It's just the x. Oh, that's nice. What's that antiderivative? So it's the antiderivative of just dx.
X?
Just x. X log x minus x. Or you may see it written as x times the quantity of log x minus 1. Good so far. When we get the table of integrals, you're going to see 6 reduction formulas, one for each of the 6 trig functions. The sine reduction formula is derived in the video. We're going to do the cosine reduction formula now. The other 4 derivations will be left as an exercise. Not to be confused with the cosine reduction identity. we want to derive. So start with the left-hand side. Clearly going to be an integration by parts. You can't do change a variable here. But what are we going to let u be? And what are we going to let dv be?
Sign.
For
You can assign an x.
so that your d here would just be dx. If you do that, your next antiderivative, n times x times cosine the n minus 1 of x times the negative sine of x. That is a nasty antiderivative. Do a very common trick in mathematics. Isn't cosine to the n just cosine to the n minus 1 times cosine? Let u be the cosine to the n minus 1. What are we left with? Just cosine of x dx. So that's our dv. dv is the easier one. What's v going to be? So what's the antiderivative of cosine?
Sign.
Just sine. What is the derivative cosine to the n minus 1? power, n minus 1, times cosine, power minus 1. Now we need chain rule.
Minus sign.
U times V minus the antiderivative of V du. N plus 1 is just a constant, isn't it? Negative n plus, not plus, sorry. Negative n minus 1. So that can just be factored right out of the antiderivative. Could be left with cosine to the n minus 2 times sine squared. Ugh, well that just doesn't look nice. But it is. How can you rewrite sine squared? It's one of the most basic trig identities.
Ln minus cosine squared.
It's one of the Pythagorean identities. Sine squared plus cosine squared is 1. Distribute this cosine n minus 2 through. I'm also going to write this as two separate antiderivatives. So that's the times 1. Cosine to the n minus 2 times cosine squared. Just n?
What was minus 2 plus 2 then?
So you mean
Cosine, yeah.
cosine to the n, right? Yes, it's just cosine to the n. Oh. Wasn't that the antiderivative? So think of this as like I. I equals this nightmare minus the quantity of n minus 1 times I. So just add this quantity to both sides. One plus the quantity of n minus 1 is what? 1 plus n minus 1. It's just n. Multiply both sides by 1 over n. That's the reduction formula that we wanted. Proof is complete. Sine is done in a much similar fashion. And again, that's in the video, so you'll see that. The remaining 4 are, again, done in a much similar fashion. That's what we call an algebraic proof. No words, just a bunch of algebra. So what that means is what you can do now is if I ask you for antiderivative of, I don't know, let's say cosine to the 11th. Instead of having to do integration by parts every single time, just use this formula where n is 11. Here you're going to wind up with cosine to the 9th, which means you'd use it again with n being 9. Right? You'd be left with 7, you use it again with n being, and you keep doing that until you'll wind up with this being just the antiderivative of cosine, which is sine. It's going to be a lot of work, but it's less work than doing integration by parts every single time. Let's look at secant cubed. We'll not be using the secant reduction formula. What are do you think? What's U? What's D? Well, dV is going to be what's left. What's U? What is it?
I don't know how to pronounce it. SCC.
Just secant? Then dV is what's left.
Yeah.
There's more than just the x left if your U is just secant.
Oh.
Secant squared, isn't it? Doesn't seem like you're committed to that choice.
No, I meant to say the first one, like, secant to the power of 3.
This is how science works. Because that's correct. You mistakenly said the correct answer. It's how science usually works. They make a mistake in the lab and make a new discovery. It's actually how alcohol was discovered. It's a mistake in the lab, in an Irish lab, of course. And they discovered the process of fermentation. What is the derivative of secant?
Secant multiplied by tangent.
What is the antiderivative of secant squared? Again, remember what an antiderivative is. So what function has derivative secant squared? Derivative of what is secant squared? Think back to the 6 trig functions. Tangent. U times V minus the antiderivative of V du. How are we going to do that?
I forgot what is secant, like, what is the formula for it?
For formula for what of secant? Oh, the Pythagorean identity for secant squared?
Yeah.
So you want to use that?
Or maybe like somewhat simplified.
Formula is 1 plus tan squared equals secant squared. That's the identity. That's the second Pythagorean identity. So yes, that's what we want to use. To rewrite tangent squared. The tan squared is secant squared minus 1. Right, so again, I'm going to do two things at once. Distribute the secant through and split into two antiderivatives. That piece right there is the original antiderivative. So move it to the other side. Add that antiderivative to both sides. Now I have two of them on the left-hand side, right? That equals secant tangent plus what is the antiderivative of secant? This is another one that should have been derived at the tail end of Calc 1. Log of the absolute value secant plus tangent. Now just multiply both sides by 1/2, and we have our answer. Call that C1. It's just C over 2. There's secant cubed. classic example for integration by parts. E to the x times cosine of x dx. What do we want to let u be?
Cosine.
Then what does dv be? And so what's left over?
E to the power of x. Dx.
What's du?
Minus.
And what is v?
Just e to the power of x.
Just e dx. U times v minus the antiderivative of v du. How are we going to do that? So how do we have to tackle this one? We only have two techniques. Change variable doesn't work, does it? Which means we have to do integration by parts again. Right? Not going to use u and v again, because they were just used. So I'll use two letters that resemble u and v. Mu and nu. Greek letters. What's our mu going to be? That leaves d nu. As e to the x dx. What is the derivative of sine? And then nu is just going to be e to the x. We still have that e to the x cosine x. Integration by parts on this antiderivative. Mu times nu minus the antiderivative of nu d mu. Since that's a plus, those brackets I can just erase. That's just plus 1 being distributed through it. This is why this is a classic example. How would you evaluate that? It's integration by parts again, isn't it? And you're going to get back to here, and you now have an infinite loop. Unless you recognize that we got back to the original antiderivative. So we have to add that to both sides. And I'm going to say, you know what? No, I'm going to add the constant later. Now multiply both sides by the 1/2. I'm also going to factor out that e to the x. Don't have to. And then everything's done. So that's when we go ahead and add in the constant of integration. And so you're going to have to be mindful of that. If you notice that you get the original antiderivative back, you stop and then solve it algebraically. We've done that a few times now. Antiderivative sine of log of 2x. Can we use a change of variable? Technically, you can. Is it going to be helpful? No. You could do the substitution u equals 2x. That's still going to leave you with sine of the log of u du. And we're back in the same boat. So let's not do that. This means we have only one choice right now. And that's integration by parts. What is u going to be? Sine what?
X dx.
Sine of?
X dx. 2x.
Whole thing. And so that is not multiplication.
Okay.
Right? Sine by itself doesn't make sense, does it? Log by itself doesn't make sense. They're functions. There has to be of something. It is a very common mistake. Well, that just leaves the x. Okay, so you know what v is? Ooh, this is fun. What's du? So we need this derivative. Let's see how good our Calc 1 skills are.
Is it trivial chain rule or no?
It's technically a double.
Oh, yeah, no.
You're only going to be using it twice. But yeah, you're going to have to use it multiple times. So what do we get? It would be cosine of the log of 2x times the derivative of log of 2x, which is
1 divided by 2x.
so technically it would be 1 over 2x and then times the derivative of 2x, which is 2. But the 2's are going to drop out. So we get just cosine log of 2x over x dx. Oh boy, this looks fun. So u times v minus the antiderivative of v du. Well, look, x over x. cosine of log of 2x. I think we see where this is going to lead to. That's integration by parts again, isn't it? Let's go back to our lovely Greek letters, mu and nu. So nu is just x. What is d mu? Shouldn't require much thought.
Minus sine minus 2x divided by x.
All right, it's practically the same, right, except it's now negative sign because of the derivative cosine. Minus quantity mu nu not x, sorry, 2x minus the antiderivative of nu d mu, so just antiderivative sine log 2x dx. We can distribute that negative through.
We came back to
We got the original antiderivative again. Add it to both sides. That should not be, sorry, that should not be equals there. That should be therefore. And then that becomes an implies. I'm going to also factor out that x, so I'm going to have x over 2. Plus a constant of integration. So x over 2 times quantity sine of log 2x minus cosine log 2x plus a constant. Good. I guess what's sad is, of the techniques we learned this semester, this is the easiest. Just wait till we do partial fractions. Let's look at an actual integral this time. We're going to integrate x times 5 to the x from 0 to 1. Clearly, integration by parts. And before I tackle this, I need to make a correction before I get yelled at. I don't know why I thought it was u sub, where I put f of g times g prime. That's u sub. Integration by parts is product rule, f times g. The uv one is correct. When I put uvv, that's fine. But the original formula should be f of x times g of x dx, not f of g of x times g prime of x dx. That is u sub. That is change of variable. That's the chain one. This is integration by parts. What are we going to let u be?
X.
And then what does that make dv? What is du?
One.
So just dx. What is v? So in other words, what is the antiderivative of b to the x? b to the x over log of b plus constant. That is the antiderivative. So that comes from the fact that the derivative of b to the x times log of b. Then what is the antiderivative of 5 to the x? Using that known antiderivative. And just a simple substitution, isn't it? What's b?
X over a line of 5.
And remember, log of 5 is a constant. So that gets evaluated from 0 to 1, right? So u times v, evaluate that from 0 to 1. minus the antiderivative, or not antiderivative, sorry, the integral, this is an integral, 0 to 1 of v du. Remember, log of 5 is a constant, so I just factored it out. Evaluate this. At 1, what's 5 to the 1? Just 5, right? Times 1 is 5. At 0, what does it evaluate to? Just 0. 0 times 1. Alright, good. So we just get 5 over log 5. Minus. What was the antiderivative of 5 to the x? Right? 5 to the x.
Over ln 5.
So this now becomes a square. That gets evaluated from 0 to 1. And quick reminder about notation. Those are the same. That's not. That last one is log of 5 squared, which is log of 25. Five to the 1 is 5. Going to be minus a negative, so it's going to be plus. What is it at 0? 1 over log squared of 5. Minus 4. 5 log 5 minus 4 all over log squared of 5. Or if you're really ambitious, what's 5 to the 5th power? Oh, 625 times 5. 5 to the 4th is 625. So that's what? What was it?
3, 125.
Sounds right. And then what you do is you just erase the scratch work. It's obvious. So you could also write this as log of 3125 minus 4 all over log squared of 5. That's fine as well. Either one. And remember to keep your answers exact unless you're asked otherwise. this one. This one's more interesting. How are we going to do this one? So glad you asked. Start with a change of variable. Let u be the square root of x. What is du then? So what's the derivative of root x?
One over two multiplied by x. With the power of minus 1 over 2.
Right? Or 1 over 2 root x. Same thing. But wait a minute. Didn't we just say that root x is u? So that makes du dx over 2u, or dx is 2u du. Our integrand now becomes 2u e to the u. What do you have to do if you use change of variable? In other words, 0 to 1 was for what? For x, wasn't it? We're in u now. We need new bounds. What does the lower bound become? This one's easy. This one's actually really sexy. Because the upper bound also doesn't change, it's also 1. How do I get those? When x equals 0, what does u equal? Square root of 0, which is 0. When x equals 1, what does u equal? Square root of 1, which is 1. Right? Remember, u is a function of x. So replace the bounds with just u of the lower bound to u of the upper bound. Do not forget to do that.
I wasn't.
Shut up, Siri, I'm not talking to you. I don't even have Siri turned on. I have to go back through my settings and make sure it's off. I don't want it listening to me. I can factor out this 2. I don't think I will. It's not going to make a difference. How do you now do this? It's not going to be integration by parts. So we did a change of variable first, which leads us to integration by parts. Except I can't use u anymore. It's already used u. say W. What's W going to be? Which means dV has to be e to the u du, right? What is dW? It's 2 du, which means V just e to the u. Two to u e to the u from 0 to 1, right? It's W times V minus the integral from 0 to 1 of 2e to the u du. What does this evaluate to? So what is it when u is 1? What is it when u is 0? Zero, so we don't need to write that. The same type derivative is very easy. That's just 2e to the u, isn't it? That gets evaluated from 0 to 1. When u is 1, what do we get? Just 2e, isn't it? What about when u is 0? What's e to the 0? 1. So we just get 2. Oh, look at that. 2e minus 2e. That integral is just equal to 2. Questions on integration by parts? This is the key step. Choosing your u and dv. If you get that wrong, you're in for a world of hurt in the problem. Because it is not going to work out nicely. But you should see that within your first step. If your second antiderivative is more complicated than the original, you chose your u wrong. Go back and try again. It shouldn't be any more complicated than the original antiderivative. Right? In the case of the e to the x cosine x, you got one that was same complication, right? You got e to the x sine x out of that. Same level of complication. It wasn't anything more complicated. If you chose wrong here, and you said that dv was 2u, your v is now u squared. dw would have still been e to the u, right? You would have gotten here, u squared e to the u, more complicated than 2u e to the u, so you did it wrong. Stop, go back, and choose again. If we get the replies, first discussion assignment are due tomorrow. I think today's the 29th. Yeah. Due tomorrow. Start working on the math assignments. I would recommend you try to finish the first assignment. That's integration by parts, but those first 7 assignments, as a reminder, will be due February 21st. So start working on those. Have a good night. See you Wednesday.